Here I will be showing you three very interesting things. The first thing is a basic difference between arrays, only one basic difference. You have seen that arrays and arrays with pointers are almost same, but there is a basic difference between arrays and arrays with pointers. So what I mean to say is, you understand that if I declare int an, it is same as, I just declare int an, it is same as declaring the array like this, int star a followed by a is equal to malloc exact size n into size of int. The exact size may be entered by the user, n into size of int. This is how you declare an array with a pointer. You may, if it is int star a, you must just typecast it to int star. So this is the way you declare an array. Then you do whatever thing is needed, followed by a free a at the end. When you are completed doing with the array, you just free that a. So this int an is as good as doing it like this. Int an will declare an array of size n, that is starting from a is the memory location, starting from a, few memory locations are declared like this, few memory locations are automatically reserved like this, and so on. So you can understand this. Now what I can say is, if you write int star a followed by int star malloc, it's the same thing, because int star a means a is an address, no doubt. Now once you do a malloc n into size of int, then that many memory locations are automatically allocated. I think you understand this, is not it so? Now how many memory locations? The difference, one basic difference is that the number of memory locations n, that is defined by the user. Here the problem is that if you hash define n as 100, then int an will automatically declare 100 integer space, that is 200 memory locations, 100 into 2. But then you might need only 6 or 8, so the rest is a waste. In the same way, you can think that instead of say 4 or 6 or 8, we may need 200 memory locations. In that case, even 100, allocating 200 memory, 100, writing n as 100 and allocating 200 memory locations might not be enough, because I may need 400 also, I may need 600 also. But over here, I am allocating exactly that amount of memory location which the user needs. If user says 200, we will allocate 200 integer space, we will allocate 400. If user says 300 integers, we will allocate 300 into 2, 600 integer space. So this is one basic difference. But believe me, there is another basic difference between these arrays and arrays with pointers. What is that? That is, if you write int star a is a pointer. At some point of time in between, you may write a statement like a is equal to a plus 1. You can write a statement like this. In that case, what will happen? A plus 1 should mean the next memory location, but integer takes 2 memory locations, so the next available memory location is this one. So this is a plus 1. So this is a plus 1 means if you write a equal to a plus 1, a might shift and a comes over here. So see, previously, prior to a equal to a plus 1, what will a0 mean? A0 will mean this. Please try to understand this point. This is a is the address. So what is a0? A0 is star of a plus 0, that is star of a, that is the content of the memory location a. So no doubt this is a0. But suddenly you write a equal to a plus 1, then this was a plus 1, but you write a equal to a plus 1, a comes over here. So from now onwards, a is this. So prior to this change, this was a1. But once you write a equal to a plus 1, a comes over here. When this was, check this, when this was a plus 1, this was a1. But once you write a equal to a plus 1, it is a which comes over here. A now comes over here. In this case, what will a0 mean? A0 will mean this, and this thing will not be, you will not be able to access this. This will be a0. So next will be a1, which prior to this was a2. Next will be a2. I think you understand this. If you write a equal to a plus 1, a comes to the next memory location. So automatically a0 will mean this one only, which prior to this was a1. So that you can do when you write int star a. But when you write int a n, this a becomes a constant pointer. You cannot change this. That is, a equal to a plus 1 is disallowed. This is disallowed when you declare like int a n. Declaring int a n makes a constant address which you cannot change. That is, a changing of a is not allowed. Even a statements like a equal to b, where b is another pointer, is also not allowed. That is, a equal to a plus 1 like statements are disallowed. Whereas over here, if you declare like this, then statements like a equal to a plus 1 are allowed. So see, I do something like this very interesting now. I show you. Say suppose I declare int star a, I use small n. Now I tell the user printf enter the number of elements. I ask from the user. So user should enter the number of elements. I scan it. Just a normal program I am writing. Scanf %d %n. Now I have scanned the number of elements. Now I tell the user printf enter the n elements one by one. That is, enter the n, I should write %d elements one by one. Is not so? I should write like this, enter the %d elements one by one, a /n, and here n should replace the %d, and then I should scan the elements in a for loop. So for I has been declared, I equal to 0, I less than n, I plus plus, I should scanf %d ampersand ai. I can do that. That is, I can also write a plus I, or just for understanding it like an array, I write ampersand ai. It's all the same. Ampersand ai and a plus I are all the same. I scan it now. Now what will I do? I will print the array. Whatever array I have scanned, I will print it. So let me copy this part. I copy this part. Now I will paste this part. So now the change that will happen is printf the array is, the elements of the array are. I can write that. So instead of writing this, the elements of the array are, and I get rid of this thing, and this n is no more needed. Now for I equal to 0, I less than n, instead of scanf, I printf the array. Printf %d ai. So the array must be printed. Only check this part only. What have I done? I have scanned the array and I have just printed the array. Let me comment this one out. Now I will show you what I actually want to show you in this lesson. See, I have only scanned the array and printed the array, as simple as anything. The first array program maybe. You have scanned the array one by one, now you have printed the array one by one. See what happens? I have declared int, I have taken int star a, so I must firstly malloc also. I did not do that. So a is equal to int star, sometimes we miss out very basic things, malloc n into size of int. See, exactly exactly the needed size I have taken. I have malloced a equal to int star, malloc n into size of int. Also a free a is needed at the end because I have mallocked. I told you, if you malloc, you also should free. So see what I have done. I have mallocked exactly the size that is needed and then freed also. I scanned the array one by one and I have also printed the array one by one. So let me now run this program. Alt R, enter. Enter the number of elements 6, 56, 43, 9, 87, 3, 29. 6 elements. The elements of the array are 56, 43, 98, 9, 87, 3, 29. Very difficult because I have not given the space. It is very important to give a bit of gap. I have not given that. So once more, Alt R, enter. Enter the number of elements 6, 7, 9, 23, 26, 79 and 2. The elements of the array are 7, 9, 23, 26, 79, 2. Done. So this is very, very simple. I can do that. Now I make a small change. Over here, after printing the elements of the array, this is the elements of the original array. Original array. Now I make a small change. Over here, suppose I printf a0, just the value of a0 I print. I write a0 is equal to %d. It will show me exactly a0. a0 equal to %d. Over here I put a /n so that it prints in the next line. /n, a0 equal to %d, and the %d I replace by the actual a0. What will it show me? The values. So if I run it, Alt R, enter. Enter the number of elements, 5 elements, 5, 9, 2, 4, 3. The elements of the original array are 5, 9, 2, 4, 3. A0 equal to 5. I have just printed that. So in this way, suppose I print all the elements like this. I don't use this. Instead, I print exactly like this. Instead of %d, I write A0 equal to %d. So A0 I cannot write. I write A %d is equal to %d. Where the first %d is I, the second %d is AI. See what happens. When you come with I equal to 0, you are writing A %d. This %d is I. So A0, I is 0. You have started with I equal to 0. So A0 is equal to the value of A0 it is printing. AI is replacing this %d. Next I becomes 1. So A %d. This is being replaced by I. So A1 equal to %d. This is A1. And so on it is printing. So instead of giving a gap, here I put a /n. Let me run this program. Alt R, enter. Enter the number of elements 6, 89, 76, 43, 20, 70 and 12. I have entered. So see, A0 equal to 89, A1 equal to 76, A2 is equal to 43, A3 equal to 20, A4 equal to 70 and A5 equal to 12. I have done that. Next what? Next what I do is a small change now. I write A is equal to A plus 1. I write A is equal to A plus 1. Now I just write printf. The elements of the original array was this. Now the elements of the new array, the array has changed. Remember what I was telling you? A was over here. So A0 was this. This is A1. Initially this is A1 because this is the address A plus 1. A plus 1. So this is A1. But now I write A equal to A plus 1. So A comes over here. This becomes A now. If this is A now, so this is no more A1. What is this? This is A0. This becomes A0 because this is no more A plus 1. What is this? This is only A. I have just changed it. So this is A now. So definitely this becomes A0. So if I now print the array once more, That is, after the change, I again copy it and print the same thing. I have copied this. Now I print it again. After the change, I print it. Print if the elements of the array, sorry, this thing, the elements of the array after the change are, for I equal to 0, I less than n, I plus plus, printf, again I write a0, a1, a2, a3 and so on up to a less than n, I print everything. Let me see what happens. Let me see what it prints, because a0 should be changing. I have written a equal to a plus 1. So let me print this again and see what happens. Alt R, enter. Enter the number of elements, 6 again. 76, 89, 23, 38, 7 and 25. 6 elements. See, the elements of the original array are a0 76, a1 89, a2 23, a3 38, a4 7 and a5 25. Absolutely correct. a0 was 76, a1 was 89, a2 was 23, a3 was 38, a4 is 7 and a5 is 25. Now see what you have done. You have written a equal to a plus 1. So once you have written a equal to a plus 1, the pointer has changed and come to the next memory location. So a0 is the content of the next memory location. So see, whichever was a1 previously, that is now a0. a0 is 89. Whichever was a2 previously, that has become a1. a1 is 23. a2 is 38. a3 is 7. a4 is 25. And a5 is 0. Why is it printing a5? Because you are again printing up to less than n. The count is same. N is 6. You have asked it to print 6, the count is 6, you have asked it to print from 0 to less than 6, that is 0, 1, 2, 3, 4, 5. So it has printed 0, 1, 2, 3, 4, 5. What is A5? A5 is the content of the next memory location which you have not initialized. By default it is 0, so it is printing 0. Here you should not have printed up to A5 because you know that one element has reduced. You have brought the array, you have brought the starting of the array to the next memory location. The array was starting from here, but you have brought the start of the array to the next memory location over here, which means that one element has reduced. Previously there were 6 elements. Now it has started from here, so there are 5 elements. You have changed the starting point. A equal to a plus 1 has changed the starting point. So there are not 6 elements at the moment but 5. So just I should continue up to less than n minus 1. Is not so? Let me run it once more. Say 5 elements this time. 8, 7, 9, 2, 5. The elements of the original array 8, 7, 9, 2, 5. A0, 8, A1, 7, A2, 9, A3, 2, A4, 5. Elements of the array after the change A0, 7, A1, 9, A2, 2 and A3, 5. Is not so? I think you get it. This is very simple. So this is how you actually change the elements of the array or change the pointer position. But what was I telling you? This is possible when you declare the array with the help of a pointer, because here a is a pointer which you can change. When you write int n, then also a is a pointer, same thing, but this a gets declared as a constant pointer which you cannot change. A constant pointer which you cannot change. So say for example I don't declare as int star a, I declared it as int a capital N. So definitely you need a hash define. I have done that. Int a n capital N. So here the malloc is not needed. The malloc is automatic. This an automatic malloc. In fact, if you write malloc, then also it will give error because a is a constant pointer which you cannot change. So here free is also not needed. But see, this is also an error. Alt R, enter. Errors 1. L value required. Function should return a value. Actual thing what it means to say is a equal to a plus 1 is a wrong statement, because when you say int a n, A is a constant pointer, otherwise everything is same. Otherwise everything is absolutely same. Like over here, if you change this, if you don't use this one, the program will run. But this time A does not change. If you don't write A equal to A plus 1, A does not change, so it will print the same thing over here. Is not it so? But still I want to show you that this will run. See, this is running. 5, 7, 8, 9, 2, 3. Elements of the original array A07, A1, 8, A2, 9, A3, 2, A4, 3. You have not changed. So only it has printed A0, A1, A2, A3. Same things it has printed. 7, 8, 9, 2. Array has not changed. Because A equal to A plus 1 was avoided. Why is it not printing A4? Because you have printed up to less than n minus 1. That is, you have printed up to less than 4. So it has printed up to 3. But you could not change the array position. A0 remains intact. A1 remains intact. So this A equal to A plus 1 is not possible if you declare it as int an, which was possible when you were declaring int star A. For the same reason, A equal to int star malloc also would have given a wrong result if you use int an, because A is a constant pointer. Here also you cannot keep A in the left side. It's a constant pointer. You can never change this A if you declare it as int an. But if you declare it as int star A, then this is possible. Malloc is possible. Printing this A equal to A plus 1, doing this A equal to A plus 1 is possible. So could you understand this single difference, this another difference between arrays and arrays with pointers? Have you understood? I think you have. I will now go and tell you one more interesting things about pointers, which is maybe a sort of relief sort of thing. You are doing a lot of complex programs, a sort of relief I want to give you. Say for example, I want to tell you a small thing. That is one small problem that I want to give you. The problem is I want to use a variable. I want to completely scan that variable, then print it, but I cannot declare that variable. Say A is a variable. I cannot write int A, but somehow I will scan A, I will print A, I will do everything. I will scan the A, I will print the A, but you cannot declare the variable like int A. Is that possible? It is possible by declaration and using variables only with pointers. What do I mean to say? I will not declare this variable A. Instead of declaring the variable A, I will declare a pointer. Say int star P. This P means, suppose I was wanting to declare a variable A. This is a variable A which I want to declare. Then I would like to scan this A by using ampersand A, scanf %d ampersand A. So if I declared a variable like this A, the next statement to scan it could have been scanf %d ampersand A. Then printing this variable would have been done by printf %d A. Is not so? So the address of A would have been scanned and this A would have been printed if A is a variable. If you declare int A, if you write int A. So if you write int A is a variable that is declared, you can scanf %d ampersand A, the address of A, scanning needs the address of A, and then you printf the variable. Instead of that, I write int star P, as if P is the address of this A you are wanting. You are wanting P to be the address of this variable. I don't declare int A, but I use P, I have used the address of A. I write P equal to int star malloc, size of int. Not n into size of int, only size of int. So what am I doing? I have declared an address P. Int star P only declares an address P. After that, P equal to int star malloc size of int declares this location, or assigns or allocates memory, or allocates memory for this variable, and that address is contained in P. Please see this. Memory allocation of size of int, malloc size of int. So this is containing this, what you are doing is you are allocating memory for an integer. So integer memory has been allocated. You have received it in P. So P equal to int star malloc size of int. So this is P. This is the address. You got it? Now you want to scan it. You have not declared A. You have used P only. Now you say scanf. Scanf what? You don't need to declare this A. You only scanf %d P. P is the address itself. You don't need to write ampersand. P is the address itself. Ampersand A is same as P. So scanf %d P. Then you write printf %d. Using P only, what will you write? Printf %d. Not ampersand, not P, but star P. This is comma, sorry. Printf %d star P. What is star P? Content of P. Content of P is this A itself. So printf %d star P. You have printed this. So I think you understand this. P equal to int star. You have allocated memory. You have done that. One thing to do better thing to do is you can write the address over here. You can write the enter over here. Printf. Sorry, one. So printf enter the variable. Okay. So user will enter over here. It is expected. And you scan it in P and printf star P. I think you understand what I mean to say. Instead of writing int A, then scanf %d ampersand A and printf A, I was scanning this variable through its address ampersand A and printing it. Instead of doing that, I am taking a location, memory location, an address. I am using malloc to allocate memory for that. Then I am saying enter the variable. I scan the address of, I scan the variable using its address P itself. So automatically A is scanned. Is not it so? Because I am putting this address, and then star P being printed means the content of that memory location is printed. One thing is needed at the end. What is that? You can do free P. Is not it so? Let me run this program now and see whether it runs properly. Let me comment out all this. This is commented. This whole thing you comment out. Let me run it now. Alt R enter. Enter the variable 6. 6 is printed. I think you understand what I mean to say. This was just a relief of a program that I was wanting to give you. Anyway, one more thing I would like to tell you before I get into the next complicated thing of 2D arrays and pointers. What is that? You know that I was always using swapping sort of thing, swapping two variables. Now for swapping, what I was doing, I was using temp. Now a problem that I want to give you, can you swap without using temp? Swap without using temp? Is it possible? See, when you are having A equal to 5, B equal to 3, you are writing temp is equal to A, B is equal to, A is equal to B, and finally B equal to temp. So what was happening as a result? Temp equal to A makes temp equal to, A means 5. Then A equal to B makes A equal to how much? 3. And B equal to temp makes B equal to how much? B equal to 5. So at the end of the whole thing, A is becoming how much? 3. See, A is 3 and B is becoming 5. So the swapping occurred. Without temp, if you write A equal to B followed by B equal to A, a statement like that, will it work? See, A equal to 5, B equal to 3 initially. A equal to 5, B equal to 3 initially. If you write A equal to B, what happens is A becomes 3. But what is B? B is still 3. So B equal to A makes B equal to 3 again. So this means at the end of it, A becomes 3, B becomes 3. Swapping does not happen. So can you swap without using temp? Yes, we can. There is a way. A equal to 5, B equal to 3. I write A is equal to, I don't use temp. I write A equal to A plus B. A becomes how much? A becomes 8. B becomes, B is how much? B is still 3. Initially A is 5, B is 3. Check out, A is 5, B is 3. A equal to A plus B. A is 8 now. B is still 3. Now you write B is equal to A minus B. B is equal to A minus B. A equal to A plus B. A was 5, B was 3. So 5 plus 3 makes 8. A is 8 now. B is still 3. Now I write B equal to A minus B. A does not change. A is still 8. And B equal to A minus B makes B how much? Makes B equal to 8 minus 3. What is that? 5. B is B equal to A minus B. So what is B at the moment? B at the moment is 3. So A at the moment is 8. 8 minus 3 is 5. That goes to B. B becomes 5. Now next line I write A equal to A minus B. So what happens to A? A becomes, see, A is 8 at the moment. B is 5 at the moment. So A minus B, 8 minus 5 is 3. So what is A at the moment? A becomes 3. And what is B? B becomes 5. You understand? So at the end of it, what do you get? A equal to 3, B equal to 5. Swapping happened without using temp. You can run it and see at the see for once yourself. See this? I get rid of all this. Now I want to run this. See, int A equal to 5, B equal to 3. A equal to A plus B, B equal to A minus B, A is equal to A minus B. Now you printf after swapping A is equal to %D, B is equal to %D. Now you just put in the values of A and B. After swapping, A is equal to %D, B equal to %D. Just put in the values of A and B over there. See what happens. Alt-R, enter. Oh, sorry, I did not comment. So this one is needed. Commenting is definitely needed. This was for your understanding purpose of the program. So now I run this, Alt-R, enter. So after swapping, A equal to 3, B equal to 5. So A was 5 initially, B was 3. You can scan that from the user and also see. Isn't it so? You can scan the values and also see. So this program will run fine. Everywhere you can scan it and see once. Printf, enter A and B. Entered A and B, followed by colon, /n and all this, and scanf A and B, scanf %D, %D, scanf %D, %D, ampersand A, ampersand B. Isn't it so? Let me run it. 2 errors, undefined symbol A, undefined symbol B. What did I do? I did not declare the A and B. I somehow deleted that also. Anyway, Alt-R, enter. So enter A and B, say 6 and 89. After swapping, A is 89, B is 6. So I think you understand this program. So we will take a bit of break over here. We will come back with what? 2D arrays and pointers. What is the relation between 2D arrays and pointers? Thank you so much.